Hey everyone, good morning, good afternoon, good evening. Let me get this set up and ready to go. Happy Wednesday. Thank you for being here today. Awesome. Eduardo, can you confirm that the slides are up?
Yep, looks good.
Perfect. Thank you so much. Awesome. So today we're going to talk about getting started with OpenTelemetry for mobile using Embrace specifically. So, just to introduce myself really quick, who am I? My name is Sergio. I am an iOS solutions engineer at Embrace. I started in January, and at Embrace, we solve problems for engineers using production data. And that's essentially what observability is. That thing that's out there right now, running on all those different devices, go learn about it, fix things, make things better. So I've been an iOS engineer for about 6 years, and prior to joining Embrace, I didn't have any sort of insight on observability. So this has all been kind of new to me in the last few months. And it took me getting to Embrace to realize that at my previous positions as iOS engineer, iOS developer, I wasn't totally incompetent when it came to mobile observability, finding bugs, finding trends. It's just really hard. Especially, I've been doing this for several years now, that tools from years ago made it even harder. So glad to be here, glad to be at Embrace. We're going to get into that here in a second as well. So, what are we going to talk about today on the agenda? We're going to talk about mobile observability specifically. So, just to kind of let you guys know, at Embrace, we started off specifically with mobile observability. So, we support Android and iOS native, Flutter, Unity. uh, Re- React Native. I don't know if I said React Native. And now we also support web, but specifically for this webinar, we're going to stick and talk about the mobile observability, the gaps, the challenges. We'll talk about that. Our SDKs and our vision for Embrace is to be built on OpenTelemetry. So we're going to talk about why that matters and how that's helpful specifically for mobile. The Open Telemetry SDK we'll get into is open source, so anybody can just uh, pull down from Git, set it up, configure it to their needs specifically, and get telemetry data from their apps. It's hard, you'll come to see, and I'll show you like a code example as to what exactly you have to be thinking about when talking about that, and then show you what the Embrace SDK, how that would make it easier as well. When you have OTel specifically, you can actually integrate with existing tools such as Grafana, Honeycomb, Datadog. You can forward these metrics to other vendors that allow you, say your organization is at a specific vendor for their backend observability. You can kind of aggregate that all together to have kind of a single pane of glass vision, which is really awesome. So I'll explain that, kind of show you a quick example there as well. Great. We'll wrap it up with the benefits and business impact of all of this. Like, what's the purpose of why are we doing this? Why does it matter? And then we'll get to some Q&A next steps. So yeah, as far as Q&A goes, folks, please, um, any questions that might come up, please put them in the chat. And Eduardo here will help me out with vetting them. And then we can get to that at the end, get them all answered. So yeah, appreciate you all. Awesome. So the mobile observability gap. So the broader mobile industry reality is uh, release cycle problems specifically. So unlike backend systems where you can deploy, get immediate feedback, mobile apps go through development, testing, apps to review, probably rejection, apps to review, maybe rejection again, eventually you get approved and you get gradual rollout, and then you can have the opportunity potentially to catch meaningful data collection. But this creates a 4 to 6 week feedback loop that makes learning extremely time consuming. By the time you get answers about performance change, you've moved on to other priorities. And with software, just things move so fast, and teams often forget what they were originally trying to measure. Most mobile teams track traditional performance metrics, P50, P75, crash rates, etc., but they don't answer the critical question: how does this technical change affect real users? So, for example, startup time improved from 3.2 to 2.9 seconds. Sounds good. That's awesome. Like we probably did some sort of optimization in the code, but what was the real user impact? And surprisingly, digging into this data might not seem like a lot, but even those few milliseconds do matter. Without user context, teams optimize for metrics that may not move business needles. And with observability, the backend centric observability is mature. So traditional observability tools were designed for server environments with predictable network conditions. Most companies have excellent visibility into their APIs, databases, and infrastructure. But the mobile app, where users usually interact with your product, it remains a black box. This creates a gap where technical teams can see backend performance, but miss how users actually experience the product. And then this becomes the challenge. Teams know their app crashed 50 times today, but they don't know which users were affected or what they were trying to do. Performance improvements show up in dashboards, but they don't correlate with user engagement metrics. Product teams use analytic tools, engineering teams use APM tools, but there's no bridge between the technical performance and user behavior. Without this connection, it's impossible to prioritize what performance work will actually matter to your users. There's so many different things you can optimize within your app that you ship to production, but working on what matters is important, right? Especially given the time-consuming nature of most things. So why does this matter more than ever? More mobile apps are often the primary interface between businesses and customers. User expectations for performance are higher than ever. Any lag or failure directly impacts conversion and retention. Companies invest heavily in their backend observability, but leave the critical mobile experience unmeasured. Why? Because it's hard. They don't know how to do it, right? The result is teams make technical decisions without understanding user impact. It's essentially guessing. So this sets up why traditional approaches fall short and why a mobile specific user-centric approach to observability is essential. So part of this talk is OpenTelemetry. What is it? Why does it matter? And why does it matter for mobile specifically? For those of you that don't know or aren't familiar, that is the OpenTelemetry logo. So if you ever see that telescope, that's typically talking about OpenTelemetry. I have an Embrace t-shirt that says, I heart OpenTelemetry. And every time I wear it, people say, oh, you like telescopes, you must be in astronomy. No, it's OpenTelemetry. So don't get into that usually with people because it's kind of nerdy and in the weeds. So let's talk about the strategic value of OpenTelemetry for mobile. Probably one of the biggest things, and this is the thing that I put at the very top, is the vendor lock-in problem. Most mobile monitoring solutions are proprietary black boxes, which I'm sure some of you folks who are mobile devs might know that there's certain semantics in ways that uh, the other monitoring solutions have that don't translate to others. You can see your dashboards, but you can't extract the granular data or integrate that into your existing observability stack within your organization. If you want to switch vendors, which is like, you get to the point where cost becomes an issue, you'll lose all of that historical data and have to hand it over to the vendor that you're currently using. Teams end up with multiple monitoring tools that don't talk to each other. Then there's that learning curve that everyone has to kind of have to get in touch to try to understand each system. Everyone has to have their own logins and such forth. The OpenTelemetry is a standard provides this standardization advantage. It's backed by all major cloud providers and observability vendors. It's relatively new as of the last couple of years. but because it's been accepted as this standardization, it's not going anywhere. It's the W3C of observability. The skills are transferable. Engineers learning OTel can apply that knowledge anywhere and reduces training overhead compared to learning vendor-specific tools. So when we're talking about the integration, most companies already have observability infrastructures, Grafana, Datadog, New Relic, uh, with proprietary mobile tools. You end up with mobile data in one place and backend in another. In my experience, mobile was always kind of, for lack of a better term, like the unloved stepchild, is how we felt on the mobile team. OTel allows mobile data to flow to your existing observability stack. One dashboard to rule them all, single pane of glass, another term. You can see all your mobile crashes next to your backend errors, correlate user actions with API latency. Another benefit here is data interoperability. So raw telemetry data in standardized format means you own your own data. You can change your analysis tool without losing your historical context. You can future-proof against vendor changes or price increases, as I mentioned, and enables custom analysis or correlation that a vendor dashboard doesn't support. So you can build your own essentially. There's a point here that I want to talk about that I call the correlation gold mine. So essentially, a user reports that your app is slow. With OTel, you can trace the mobile tap that a user does to the API call, to the database query, to the response, to the UI render, which is amazing. The backend sees, like, here's another example. So the backend sees 500 errors at 3 p.m. With mobile traces, you can see which users' actions triggered them. Mobile performance issues often manifest as backend load. OTel helps you see the full picture. And instead of paying for separate mobile monitoring, backend APM, log management, unified telemetry can reduce this tool sprawl that a lot of organizations are currently living in. That gives you better ROI on all observability data that works together, and reduces the context switching between different vendor UIs. And why does this matter for mobile specifically? Mobile performance directly impacts business metrics, conversion, retention, app store ratings, but mobile issues often originate in your backend systems. Without unified observability, you're debugging mobile issues with one hand tied behind your back. Mobile bridges the gap between the app is slow, or sorry, OTel bridges the gap between the app is slow and here's exactly how you fix it. This positions OTel not just as a technical choice, but as a strategic business decision for better mobile observability. So we're talking about this, sounds great. This is awesome, but the reality is the manual OTel setup is hard. It is really hard. At Embrace, we are open source in all of our SDKs, all our OTel SDKs. So you are free, and we actually encourage folks, if they're genuinely curious, to go into GitHub, pull those down, try to set that up, instrument your app. And here an example, I'm gonna actually pull down the vanilla OTel iOS SDK and kind of show you what you have to take into account. But it's complex. Manual OTel requires installing the core SDK, plus multiple instrumentation libraries. A lot of them. It's a pain. For this webinar, I got that set up, and it was kind of a headache. Each platform, iOS, Android, has different set of procedures and limitations. You need to configure exporters, processors, samplers, a lot of moving pieces. So us mobile developers, not really even knowing much of like observability and all of this, it's a lot to learn, a lot to take in, a lot to understand. Language specific complications, Swift, Objective-C, Kotlin, Java, version compatibility between OTel components. I also want to get into specifically like network reliability issues. So backend systems assume reliable network connections for telemetry export. Mobile devices frequently lose connection, switch networks, go into airplane mode. We're maybe thinking if we're US based, like that might not seem too much of a difference, but when you look at a user base that's globally, there's a lot of different factors that you need to take into account when you're doing this. Data can be queued for hours or days before transmission. OTel exporters weren't originally designed for this level of network instability. Huge thing right here. And this is just when you actually take a look at it, if you play around with it, it's mind blowing how like granular it gets. But battery optimization features, they can kill network requests in the background. And so you have to be very careful about that. The device fragmentation nightmare. So there's just thousands of combinations. Obviously, when we think about mobile device fragmentation, it's very easy to think about like Android and the thousands of devices that they have. But not only are we thinking about the specific devices, but we're also thinking about the combinations between the devices and the OS versions as well. So yeah, you think about iPhone doesn't have nowhere near as many Android devices, but all of the different OS versions, major, minor versions, it's crazy. So given that, the performance characteristics vary very wildly. What's fast on a flagship can be slow on a budget device. And given this challenge, given this thing that we're talking about, the aggregated metrics can become meaningless. So like you think that your P50 latency is 200 milliseconds, but for which devices? And if that question matters because, if you just do it all together, like, yeah, your P50 latency takes into account your 10% of your fast devices, but maybe 40% of your devices of your user base are slow. So that metric might not be totally accurate or helpful. Uh, so the need device specific context that vanilla. So you need to provide that vanilla or device specific context that vanilla OTel doesn't provide out of the box. Resource management headaches. So mobile OS strictly manages memory and CPU usage. Apps can be killed at any moment, losing the telemetry data unless you really are aggressive about saving that information, caching it. Instrumentation overhead can actually hurt user experiences on older devices. Um, so again, being very careful that the instrumentation that you set up yourself isn't affecting the user experience in any sort of way. So you need to be extremely careful about what you instrument and when. I want to talk about this bridge that Embrace specifically, like we really take into account. It's the missing user context problem. So traditional mobile monitoring limitations, so like such as Firebase, prime example. So many organizations use Firebase. They are heavily sampled and they have limited insights essentially. So you can possibly figure out where your line of code crashed, but you might have to dig a little bit deeper within your local debugger and things like that. It can't link mobile data with backend data, and there's limited understanding of user behavior specifically of what the user journey looked like. Um, the so this user-centric challenge here, manual OTel gives you technical metrics, but misses user behavior context. You can't you can't easily answer which users experience this performance issue. It's difficult to correlate technical events with user actions. No built-in understanding of mobile-specific events, app backgrounding, for example, orientation changes, which is maybe something that we don't even think about, but it matters, especially in Android. Traditional span model doesn't map well to mobile user journeys. It's just kind of like just spans that are part of little bits of your code. So here's an example. So the user taps a button, there's multiple asynchronous operations. Eventually the UI updates and the spans don't capture this flow just naturally. Okay. The demo, do it yourself. You want to build it yourself. You want to set this all up. You want to be an observability nerd. Eventually, come work in Embrace. Sweet, that's awesome. I'm going to show you what that could look like essentially. And so the challenges with the native implementation is that you got to take into account the performance impact. Standard OTel Swift SDK is designed for server environments, not mobile. Battery drain, like I said, heavy instrumentation can impact your battery life. It's a lot of testing to try to get that right. Memory usage, there's no built-in memory management for mobile constraints, so you really have to be comfortable with instruments in Xcode. And again, let me take a step back and say, I, being an iOS guy, am I'm realizing now in iOS terms, but this also applies to Android and all the other mobile SDKs. So if I say iOS terms, apologize, but you can think of its parallel on your specific platform. But memory usage, there's no built-in memory management for mobile constraints. And then missing mobile context. So it lacks essential mobile specific attributes, such as device info, network state, app lifecycle. You have to essentially define that. And there's so much. So like you really have to kind of know where to get that stuff and how to look that up. So yeah, let me go ahead and show you. I have a sample project here. Um, cool. Eduardo, ooh, sorry. Let me go to, are you able to see, Eduardo, the OpenTelemetry service?
Yep.
Awesome. Cool. So for this webinar specifically, I set up in one of my sample apps that I have that I built myself here, uses Core Data extensively, uses CloudKit extensively. I went ahead and set up this OpenTelemetry service because the majority of our customers that have like the Embrace SDK or folks that I've spoke to on the OTel iOS community channel, they'll have services to essentially have these functions that they can call and sprinkle throughout the code. But as you can see, there's just plenty of there's a lot. It's very verbose, very dense in what you have to actually include here. You can add battery level. You have to set the attributes as device models. Um, you have to define literally everything. So set up app lifecycle, instrumentation, and you have to know iOS really well. You have to know your app really well, and understand where things get called, where things get started, dependencies, because the hard part here is, yeah, maybe you can set up a class, the open telemetry service, like pretty easily, but and it might be perfect, it might work perfectly fine, but if you're not putting it in the right place in your code, you're essentially measuring incorrectly and potentially inflating or deflating your numbers, report inaccurate reporting, and that could be a huge problem. So you have to be very sure about that stuff. And there's a lot of like checking, um, device orientation, app state, physical memory. You kind of have all this information here that you have to set up. And then I also have this like mobile context instrumentation as well, that helps you like set up mobile monitoring. So it's like Wi-Fi, cellular, Ethernet. And I am using, so I'm on Swift Package Manager, OpenTelemetry Swift. So this is the vanilla Open OTel Swift. There's a huge community behind it, open source. People are using it. I recommend checking it out if you are actually interested in doing this. But like I said, you have to be very granular and very specific about everything that you're defining that you want to check to make sure that you're actually getting the observability that's going to be helpful to your organization specifically. Um, and it's a lot because when right now the OTel Swift repo is just because it's so new and there's just so much still to unpack, there's changes. And so you got to be aware that if you're going to be doing this, there's going to be deprecations that you have to take into account, updating it. monitoring the different packages and things like that. So I'd recommend this if you are specifically a person who wants to take on a lot of this granularity and potentially have to, juggle a lot of things. You're basically going to be living here if you're doing that within your organization. That is a really short example of like, yeah, how granular you have to get with all these different attributes and things like that. Your performance bands, you have to define all of them. You have to sprinkle them now throughout your code, wherever you get that stuff. So nothing is automatic. Everything here is manual. And so it works, but yeah, big pull there. Let me go back to the slides here. Cool. Eduardo, do we see the demo do it yourself?
Yep, we do.
Awesome. Thank you, sir. So let's talk about the easier path. Why are we here? What are we talking about here? So the Embrace SDK. So the technical advantage here is coming as an iOS developer to an organization, maybe you are tasked to build some sort of observability. There's zero configuration complexity here. You essentially, and I'm going to demo this here in a second, but you essentially have your single SDK, instead of having to import all these multiple OTel libraries. There's no need to configure exporters, processors, samplers manually, which is something I forgot to mention as well, is yeah, you have your Xcode or your Android Studio, cursor, whatever you're using to compile your app, but then you have to export that to other vendors essentially, such as Grafana, and you have to make sure that that data is processing correctly, and you're sampling, you're batching, all of that stuff. uh, and yeah, there's also work in doing that as well. But with Embrace, you get automatic platform specific optimizations. So the iOS memory management, Android lifecycle handling. You have built-in mobile best practices for battery optimization, network retry logic, and then immediate instrumentation of critical mobile events really, with some very, very little code changes. Um, cool. So we're trying to solve mobile specific challenges with Embrace. Uh, with network reliability, we handle that. We have built-in data persistence during network outages, intelligent retry logic with exponential backoff, automatic batch optimization for mobile networks, and we handle app backgrounding and foregrounding gracefully. You'll see in our user timeline here how we do that. It's actually really cool. Uh, Device context capture is automatically captured. So, is in my example of when you're doing it manually, all of that stuff you have to define, you have to go into the documentation, make sure that you're putting it in the right place. All of this is automatically captured. The device model, OS version, app version, the metadata, and then also performance metrics are automatically segmented by device capabilities. Network condition detection, Wi-Fi versus cellular. So that's super helpful. Geography and carrier information for regional performance analysis. We also have recently really been getting into user journey focus. So sessions are first-class citizens. They're not just technical spans. User interaction timeline with technical events overlaid. Breadcrumb trail of user actions leading to issues. Correlates crashes and errors with what a user is actually trying to do. Um, And then, so value here is beyond just raw OTel. Like, what else has Embrace done to kind of have this value add? Um, on Android specifically, we capture ANR detection and analysis. That is one of the big industry things that a lot of folks uh, really appreciate how we do that. We do cold and warm startup time measurement and optimization insights. frame rate monitoring and jank detection, memory pressure and crash prediction. Uh, yeah, so with all of this, you get a complete session reconstruction to see exactly what happened before a crash, where a user was, what they did up when they first opened the app to where it finished. Network request and response details with timing breakdowns, client-side error context with backend logs miss, user flow analysis, which features are causing abandonment. Super important when you're building new features. So the business impact here is you link technical performance with user engagement metrics, identify which performance issues are actually affect conversion, segment analysis, performance impact by user cohort, geography, and device tier. And then you can do A/B testing integration, measure performance impact of feature changes. So we're developers. Why this? Uh, Embrace it provides immediate time to value. You can have full instrument, not full, but a huge chunk of your code already instrumented, and I'm going to show you guys in a second within a few minutes. And I'm always skeptical of vendors saying, yeah, just a few minutes, because I've been burned in the past before, but I will demo it. It's actually really easy. You'll have production ready telemetry out of the box. It's ready to go. You'll see that and you immediately find the value on what Embrace provides. We also have integration flexibility as well. So you might find that the Embrace dashboard is super helpful to you as a mobile developer, but you also want to make sure that the SRE teams or DevOps has observability into some mobile stuff as well. With our integrations, you can actually export uh, your OTel data to have your other teams view that in a way that they are going to be able to understand, which is super awesome. And so, what's the real world impact here? It reduces time to identify performance regressions from weeks to minutes. Proactively catch issues affecting specific user and segments before they escalate. Correlate mobile performance with business KPIs for data-driven prioritization, and enable mobile developers to debug like engineers with full context. Cool. So I talk a big game. Let me see if I can just demo this and you guys can see how easy it is. Like I said, I've always just been super skeptical of vendors and it's gonna take 2 seconds and no, but here, let me show you. Eduardo, do you see create app at the top there? Google Chrome.
No, I'm currently seeing data destinations Grafana cloud.
Ooh, oh, I tipped the wrong one. Sorry about that. How about now?
Yep. No, I see it.
Perfect. Thank you, Eduardo. So you talk to Embrace, you get access here to our dashboard, and you want to add your app to start getting telemetry data. This is what you're going to see. Instead of having to go and define within your code the platforms and getting all that stuff set up, it's a very intuitive UI. I'm going to just use iOS, for example, production, and then just hit continue. And then when we get here, uh, there's two ways that we support right now is the Swift Package Manager and CocoaPods. You download the SDK, and then this is what you'll need. You can have your app delegate. We UI kit, Swift UI, either way is going to work. Same with Android as well, Kotlin support there. So super exciting. You just copy, and it seems like it's a lot, but you really just kind of need this. And let me switch over to my Xcode screen to show you what that looks like. Share, embrace outdoors. When you get to the point where, okay, can you see embrace outdoors at the top, Eduardo?
Yep.
Perfect. This is it. This is the code that we copied and pasted from the integrate page uh, for Embrace specifically. That's all you need to do in your main file here. You can do it in your app delegate as well. When you are specifically on that page and you create a project, whether you do a develop, staging, or production, you get a specific app ID for that particular project that you're doing. And that's going to allow our backend to process and know that your data is coming from that specific project. That's all you need. Um, Nothing else. There's nothing else you need to define. You run your app, you start moving around, poking around, and then you want to see some data. So let's look and see what that looks like. Try and add this up as efficiently as possible here. Do you see the user timeline, Eduardo?
Hmm.
Sweet. So this is an example of the app that I just added on there. And I already had this kind of ready to go. But this is an example of the dashboard in Embrace specifically set up for automatic instrumentation, essentially. And the way that we do it is your user sessions, everything is captured. If the user goes into the background, we capture background sessions. And then when it goes, there's a time limit of 5 minutes. If the user comes from background to the foreground, we capture the foreground. And then within those 5 minute time frames, a user timeline is stitched together essentially. And you're able to see all of this stuff, different. So this is not fully instrumented, but you have like spans, network calls, successful. You also have a stack trace. You have your session details, which gives you all of this information out of the box. And that's where it's super helpful. Literally, all I had to do is take that chunk of code, put it in either my app delegate or my main file, put it in here, and start seeing that information right away. We've had folks that we have had try this, like POC, and they were able to find bugs within literal minutes, and that they didn't have observability into before. So that's where this is just so helpful. And then we at Embrace are very active in updating our product and adding new features to it, adding more cardinality to support stuff as it changes. So you don't have to worry about any of those changes. You can just check in with our changelog, ask our support team, or just look at what we're doing in GitHub so you guys can see all that stuff being updated there. Cool. I know we're getting close to time, so let me go over here because the last demo is going to be very fast. So we should be able to get there and get into Q&A here in a second. Do you see demo embrace, Eduardo?
Correct, I do.
Okay, perfect. Awesome. Let's move on here. So because Embrace is built on open telemetry from the ground up, all data is inherently compatible with any OTel-compliant system. It uses the OpenTelemetry protocol as a standard export format, the same protocol that your backend services use. There's no custom data transformation, no mapping required. It just works with your existing Grafana setup. And this isn't a compatibility layer, it's genuine OTel data with mobile specific enrichments. So I want to just show you, get a little, if there's any further detailed questions, we get that in Q&A. If there's questions that get a little bit deeper, I will be sure to reach out to you as well and kind of get into the weeds with you. Happy to do that. But let me share what a Grafana integration, how easy that could be with Embrace here. So I think I had that up earlier. Okay. Do you see integrations, Eduardo?
Yep.
Cool. So we already have our Grafana cloud kind of already set up here, and that's what I'm going to show you here in the dashboard. But this is the dashboard that we came from, essentially what I just showed you, where you had all that automatic instrumentation data kind of set up very neatly. But if you go into this integrations tab here, add data destination, You select your platform, and these are currently the ones that we are just kind of supporting like right off the bat: Chronosphere, Datadog, Elastic, Honeycomb, New Relic, Splunk, Observe. And it's just as easy as like if I choose Datadog, you select your specific app that you're trying to export, the API key and the site URL, and you forward your metrics to this destination. When you do that, you set it up on your other end. So for us, it's here in Grafana. You're able, so this is just an example production app that we have as a testing uh, platform here at Embrace. And so we can set all our custom dashboards here. And if your backend or SRE or DevOps teams live in Grafana, you can then show them this data, set it up custom that is going to give you the data that you need and want. And that's going to make more sense to them, given that they're probably more fluent uh, in Grafana and the dashboard. So you'll be able to see all that stuff, and it's pretty magical as to how easy it is to export it. But not just Grafana, like I said, Honeycomb, New Relic, Datadog, that all works as well. Cool. I know we're almost at time now. I just respect everyone's time here, so I won't get too uh, exploited about everything else here. But do you see, Eduardo, do you see integration story?
Yes, I do.
Perfect. All right. Awesome. So here's the summary of what we just discussed here. Key benefits. For mobile engineers, you're going to get faster debugging with full session context, performance insights, ANR, launch times, network issues, understand how technical issues affects users, which is like the big topic that we're discussing here. And then you get to build skills on open standards, which is awesome. For SREs and observability leads, unified telemetry across mobile plus your backend. There's no vendor lock-in with OTel. Reduce complexity in mobile instrumentation. Complete visibility, filling that mobile observability gap. Those words are hard sometimes. For organizations, faster time to value. Minutes again to full instrumentation. Not full. I should have edited that. I apologize, guys. Really, really, really solid instrumentation. Better user experience through mobile performance optimization, future-proof solution built on industry standards, and cost-effective mobile-specific instrumentation. Thank you so much, everybody. We are observability nerds at Embrace and look forward to talking observability. So if there's any other questions, feel free. We're more than happy to help you answer that and get some clarity as well. Yeah, thank you so much for your time. I really appreciate it.